Okay, welcome everyone to this last presentation of the day, which I've called It's All in the Mix, where I'm gonna basically be doing a tips and tricks talk on creating production-ready applications. It's rather demo-packed. It's late, and I know that I'm the only thing standing between you and beers. So we'll get started, and I'm gonna try to keep up the tempo and keep you all awake. As we all know, when we're building Spring applications, Spring Boot applications, right, there's stuff involved like building web controllers, adding security, working with databases, and a lot of the presentations at this conference are actually dealing with those topics. But I thought for this year, I'm going to talk about something else. Because what I want to do is I want to talk about how to create production-ready applications. So basically, once you have your base functionality in place, what else do you need to do to really run this thing reliably in a maintainable way in production? So think about stuff like caching, performance tuning. Packaging is actually something I'm not going to cover. I was planning it originally, but I have too many demos already. And there is actually a separate talk about all the options that you have for Docker image packaging. So I'll leave it to that. But also things like observability, right? Not just logging, but also metrics. How do you configure those so that you can see what happens at runtime? And what I also think personally as an architect and as a CTO is that it's super important that people don't treat Spring or Spring Boot just as something that you use as what it provides out of the box by default, right? It's a framework, it's not a library. So the whole idea is that you can actually make it your own, add your own conventions, your own libraries, that sort of thing, in the sense of custom auto-configuration, for example. So I'm going to be talking about that as well. Another thing that I find to be a common concern that not many people are always handling properly is error handling in the web tier. So what I mean by that is what happens when you have a controller, right? Could be servlet-based or reactive, doesn't matter. And it just throws an uncalled exception, either directly or more typically by propagating it from some service layer. What happens then? What does the client get as an HTTP response? So as you probably know by default, in the browser you would see a white label error page for that. And if you're a programmatic client, you're going to see something similar, but then in the form of a JSON document. This is very often something that you will need to customize. And a very common way of doing that is to implement a so-called controller advice. So a controller advice is something where you can add multiple things, including exception handler methods. There's some other stuff as well. And they, by default, apply to all of the controllers in your web application. So it's a very common way of doing things like error handling and making sure that the response is what you expect it to be. Also good to know, in a recent version of Spring, so 6.0 and higher, there is now also support for a new standard to return something called problem details, RFC 7807, as you can see here. It's interesting, I think, because web APIs, REST APIs have been in active use for, well, at least 15, maybe 20 years already. But this is something that everyone was just trying to figure out by themselves, right? There is stuff like HTTP status code at least, but what do you actually return in the payload of a response is not very clear. And now finally we see that some standards are emerging in that space, so that's nice. Now, very often when you have an exception, it originates maybe in a repository layer, and then it ends up in the service layer, which then throws it all the way to the controller layer. And in those steps, very often the exception is wrapped. Therefore, the exception handler methods in a controller advice first check if a given exception is handled by one of the exception handler methods directly. But if that's not the case, then they're actually going to see if there is a nested exception. If there is a nested exception, that one will be tried against all of your exception handlers. And if that one isn't matched, it's going to get another nested exception if there is one. It's going to try that, right? So it's turtles all the way down, hence the picture. This behavior, by the way, that it doesn't only do like the first nested exception, but it does all of them, is also relatively recent, but I'm assuming that you're all at least on Spring 5.3. So that's how that works, and I want to do some demos for this. So what I have here is an error handling application. The application itself basically does nothing, right? It just starts up boot, which is just what you get out of the box when you use the initializer. And then we have a controller, and the controller here has 3 methods. Is this readable in the back? I think so, yeah, perfect, thanks. What you see here is that first of all, we have a method that is called timeout, which returns a timeout. If we look at what it does, it actually uses a REST client here, which is set to a read timeout of 1 second. This is 1,000 milliseconds. And then it's calling HTTP bin with a delay of 2 seconds. So it will always result in an exception. If you're wondering why this says HTTP bin and not .org, that's because I'm actually running this thing on localhost in a Docker image, and I've just added a localhost alias on my laptop so that I'm not relying on Wi-Fi at a conference, because I have some not so good experiences with that. So that's the timeout. Then we have an unexpected exception, right? Just some runtime exception that gets thrown like that. And finally, I wanted to show that as well. We have a post here that unmarshals a JSON object that it validates. And it's a trivial record, right, that only has a single field called name. But that name must be populated, cannot be blank. And we force the actual validation by having the @valid annotation. So we can start this thing up, or maybe I did that already. Now let's start it up. And then we can make some requests. So for that, I'm going to use this IntelliJ feature where we have this .http file, which is a really nice feature of the IDE that allows you to programmatically create some requests, right? So I don't need Postman or something like that. So let's see what happens if I call the unexpected now. And what we're seeing then is we're getting back an application JSON content type with a 500. And then there are some fields like a timestamp and a status that says, oops, something went wrong, basically. But we don't see anything else, right? We don't see the exception message or something. This is just super generic error message. That's that. Then I can also do the validation. So if I call the validate, but instead of providing a name, I'm providing an H field, I will get a validation error for that. If I do that again, I will see that we're getting back, oh, let's make this a bit bigger. We're getting back a 400 in this case, bad request. Sorry, this is the timeout, I need the validation. There we go. I get back a 400 here, application JSON content type, and then we see basically the same fields again, right? So it's super similar because this is all generic Spring Boot out of the box error handling. For the timeout, I don't want this. I don't want a 500 internal server error if a downstream call results in a timeout, because HTTP defines a custom status code for this, which is 504 gateway timeout. Right? In this example, my code acts as a gateway to the downstream HTTP bin service. If that one times out, I want to return a 504 timeout. And as we'll see, if I call this endpoint, it takes a while because it's a timeout, right? And then we indeed get back a 504. And it's empty. There is no content type because there is no payload. So how did we achieve this? Because this doesn't happen by default. So for this, I've implemented an error handling advice. So you can see that here it's a REST controller advice, and it has this @exception_handler method that is called if either a timeout exception or HTTP timeout exception are being called. They're both exceptions that can be called if you're using the built-in Java HTTP client. And then we use the @response status annotation to say this thing should actually return 504 gateway timeout. Now, as you can see here, I've done some additional stuff because I want to show you something. Because I could also have added the exception here as a method parameter and then log it. But then you would really just see the timeout exception, the thing that we are specifying here. But what I want to show you is that this thing is actually a nested exception from the original exception that was being thrown. And you can access that original exception. You can do that, as I've done here, by using this servlet wrap request, which is Spring's wrapper around your HTTP servlet request. And then you extract this attribute, which has this really long name, right? Default error attributes.error. That gives me the original exception. So I can log that, and I already called this method, so I can just look at my logging now of the error handling application. And then what we see is that it said the error handling advice here had a timeout while handling the /timeout request. And that was caused by a resource access exception. So that's like, that's like the top level Spring exception here, resource access exception, which is in turn caused by a Java I/O exception over here, which is in turn caused by an actual timeout exception, which is the one that we said we wanted to handle. Right? So you get this nice nesting. Now imagine that for the 500, we don't want to have this default application JSON. We want to use a problem details error. What we could do then is go back to our advice here, actually scroll down a bit because I've added that here, and then comment this in. And now we're having another exception handler that says, you know what, I'm just going to handle any runtime exception. And again, just log it and then return this problem detail object. Right? It has a static factory method, so you can say I want to use this status code and this is the detail I want to have. This is one way of returning problem details. So let's restart and then see what happens if I do this. Error handling application, restart. So going back to my HTTP client here, if I now call the unexpected what I'm getting back now is an application problem JSON, as you can see here, that says there was an internal server error. So that worked. And let's also just check the validation. The validation still works, still returns a 400. But now, let's check if our timeout still works. And we'll see that it doesn't. Because what happens now is that the timeout also returns a 500 rather than a 504, which is also a problem JSON. And this makes sense if you think about it, because if we're looking at our error handling advice here, and we make this a bit smaller here, then what you see is that if this runtime exception is thrown, or the timeout exception is thrown, sorry, it will be matched against the first one, but well, the outer exception was a resource access exception, as we've seen, so it doesn't match that one. And then it tries this exception handler, and it says, oh yeah, runtime exception, that matches, because it matches everything. Right? It's a catch-all. So this doesn't work. And in my project, which is a big integration platform that provides a whole bunch of REST APIs to clients for the Dutch lotteries, this is something that I wanted to fix, because I want to have like a catch-all, but I still want to have more specific error handling even for nested exceptions as well. The good news is this is actually quite easy, but I only found out about this when I just read the Spring code. So to prevent you from having to do the same thing, I'm going to actually demo how this works. What you can do is, instead of having this catch-all exception handler in the same controller advice, I'm going to remove it here, we can create a separate controller advice. So another one. And this one only has the catch-all. So this is the same code that we see, right? It catches the runtime exception and logs it. I'm going to make this component scanned. You can see that this has an add order annotation. Now by default in Spring, if you do an add order, it has max integer as the value, which means its lowest precedence. So what I can do now is I can go back to my other error handling advice here and say this should have an order, but it should not be the default. It would be anything that is not integer max value, right? Anything lower. So I'll just put in 1, but it could be anything really. And what you will see now is that if I restart my application, we're getting the behavior that I'm after. So going back to the client over here, we can first call the unexpected. That still returns our problem details in the 500, so that's the catch-all that's being triggered. Our validation still works, but it already did. And then finally, we have the timeout, and now if I call timeout, we'll see that it does actually return the 504 rather than the 500. There's some other interesting things here. So the validation error, for example, it doesn't actually tell you what was wrong, right? I forgot to add a name. I should have added the name to create a person, but it doesn't tell me that. You can actually configure this. So what you can do is in application properties, you can say, I want to include binding errors. There is other stuff that you can configure here. You can see include exception, include message, include stack trace. But in this case, I want to have the binding errors, so I'm configuring that. And now if I restart, what we'll see is that if I trigger a, oh sorry, this is not the service that I need to restart. This is the one. There we go. See if it's already there. Yes. So now what you see is this. We're getting back a 400, but now I'm getting back this error string. And then I'm getting back this horrendous JSON that has this whole list of codes and stuff. This is not the nicest thing I think that Spring could provide out of the box, but this is still what it does out of the box. I'm going to talk a little bit about this in the presentation when we get there. You may also be wondering, why am I restarting this application all the time, right? Don't you use the dev tools? What is good to know is that when you do use the dev tools will automatically configure to show a whole bunch of error details, which on the one hand makes sense. If you're developing locally, it's nice if you can actually see things like stack traces in your responses, but you need to be aware of this. If you're only developing with DevTools, then you might think that you're going to see certain things in production, and then you're running on production and you don't see anything, right? So if I put this back, if I comment this out again, but now I have the DevTools enabled, I can restart. What we should see now in the error handling application here is that we're going to get a restarted main as the name of the thread, which will indicate, there we go, that the DevTools are active. And now if I trigger another exception, like this one, the unexpected, I'm actually going to get back, oh no, this is not the one. I should do the validation in this case, sorry. Because the 500 one we handle ourselves, right? But the 400 one is actually handled by Spring. So what you see here now is that in addition to the errors, we also get a trace, and we also get this message, so now all of the information is included, right? Which, like I said, makes sense, but you need to be aware of this, that this is a side effect of the DevTools. This will not happen when you actually run this application somewhere else. One more thing, and then this demo is done. You can also ask Spring to simply enable problem details, because you say, I want to have problem details everywhere, right? If you do that, what we'll see, if I now, well, actually now I don't have to restart, I can just build, because I have the DevTools, which is sort of the point of that. I can go back to my HTTP client here, and now make another validation request. And what I'm seeing now is that I'm getting back a problem JSON, even though that I did not implement anything in a controller advice for this. So this is Spring doing this based on the property. However, this doesn't provide me with any details, and as far as I know, there is no way that you can actually tell Spring when you're returning problem details for a validation error, I still want you to include some information about what was missing or what was failing in the validation. So that's like a limitation, as far as I know. But I didn't really research it in depth. But I wanted to show this because I think error handling is a really important topic. And very often people just go with the default, right? And this default error page is probably not what you want. You want to make sure that you think about this stuff, because this is the contract that you have with your clients, right? It's part of your API. It's not just an implementation detail. So with that, let's stop this application, close everything, and return to the presentation. I also showed you that if you do include the binding errors, they sort of look hideous. Actually, a couple of years ago, I talked about this in another presentation at Spring I. So this is shameless self-promotion, of course. But the reason I want to show this is if Sergey actually wants it, I hope to be speaking more often still at following Spring I events. And I think it's really cool if I can make this a thing where every year I'm going to show myself, showing myself, and do turtles all the way down, right? So this is the start of that new tradition. Hopefully. And as you can see here, I said it actually makes my eyes bleed to see the default validation errors. That's why that picture is there. So that's one thing. Also, if you are implementing an exception handler advice, you can also extend this thing, the response entity exception handler, and then all of the default Spring exceptions will be handled for you with an implementation that returns a problem detail. But again, it hides the validation errors. If you need more control than this, because this is basically what Spring provides out of the box, then I really recommend you to look at a library from a guy called Wim de Blauwe. He's actually spoken here at Spring I several times on things like TimeLeaf and HTMX, but he has a really nice open source library for configuring how certain exceptions should be rendered, basically, where you can also do stuff using annotations on exceptions themselves, for example. And I'll make sure to include this presentation in my GitHub repo, so you can actually click on these links and see this stuff. Right. So that's that. Then there's HTTP caching. HTTP caching is something that I guess most of you will be familiar with. It's been part of HTTP ever since the 1.0 spec, and it's mostly targeted at browsers, right? We're getting some static content, and then the next time I'm getting the same content, the server can actually say, hey, this hasn't changed, so you can just use your locally cached copy, and that prevents a lot of bandwidth from being used. And this is very widely supported because HTTP itself is super widely supported. So all sorts of different clients, browsers, but also programmatic clients will know how to do this. But it's very often overlooked in my experience for non-static resources, stuff that you serve from an MVC controller, for example, where even those things can very often benefit from being cached. So basically, there's two ways to do this. What you see here is a last modified error on the right-hand side. So this response includes a last modified, and if that's there, then what the client can do is can say, okay, I want to retrieve the same resource again, but I'm going to provide that if modified since. And if that thing has not been changed since the date that was given by the client, it doesn't literally have to be the same date, right? But it should be that one or later. Then we're going to get back a 304 node modified, which is empty. By definition, there should be no payload here because the idea is that the client can use its local cache. Now, date timestamps is nice for stuff like files, but for dynamic content it can be a bit tricky. So since HTTP 1.1, there's also something called an E tag. So what you see here is that the HTTP response contains an E tag. It's actually important that there are double quotes there. That's part of the standard. There should be double quotes around the value. And then what the client can do when it requests the same resource again, it can include an if non-match header with the same value. Here it needs to be literally the same thing. And then again, if the server determines, oh yeah, this thing is actually still the same, based on some hash or something, this is very often a hash, it will return a 304 not modified. Right. Now when you want to use E tags, there's basically two ways of doing it. One way is to calculate shallow E tags, as they call that. Shallow means we're just going to do all of the work on the server when the request comes in, we're going to basically create the full response, but instead of sending it out over the network, we're going to calculate a hash, and we're going to compare that to the given if non-match header. And if they match, we say, oh yeah, never mind, 304. So the benefit of using that is that it saves bandwidth and latency, right? You're not sending big chunks of data on the network, but you still have to do all of the work on the server side to come up with a response, because you can only calculate the hash once you have the full response. So as you might imagine, next to shallow, there's also deep. So that means that we are actually going to determine the ETAG value without doing all of the work. Right, so we can derive that somehow, or we can cache it somehow, or get it from metadata or whatever. And the benefit of this, of course, is that you have additional savings because you're not actually doing all of the work. You can immediately determine when the request comes in, oh, client representation is up to date, never mind. But it's harder and not always feasible because it depends on if you can know the right ETAG value up front. So how does this stuff work? I quickly want to show you that. And for that, we have another demo, which is the HTTP cache demo. And I have three things here, as I'll show you. First, the application itself is this class. It has the main method that starts up Spring Boot. But then it also has this thing. It has, let me make it full screen. We have a filter registration bean that registers a shallow ETAG header filter. So this is a class from Spring, which is just a servlet filter that knows how to calculate shallow ETAG hashes based on the response's content. That's what it does. In this case, I'm going to map it only to requests that start with /shallow. So not everything is actually handled by the shallow ETAG filter, but only these requests. Because not everything actually benefits from this stuff. Right? Then what we're going to do is we're going to start up this application, caching. And while I'm starting it, I'm also going to show you that in the resources folder, we also have a static file here. This is called static.json. It just contains some random JSON. And as you probably know, Spring Boot has built-in support for static content. So now the application is running. What we can do is we can first retrieve that static JSON. We're going to get back a response. And in the response, what we're going to see is, let's see here. We're going to get back a 200, and there's going to be a last modified header here, right? So what we can do now is we can take that last modified header, and in this case, it's literally the same value that I put in, and we can make a GET request with an if modified since. And if we do this, then for the static contents, automatically we're going to get back a 304. So for this, I didn't have to do anything myself, right? This is not the shallow ETAG filter or anything. This is just built-in Spring behavior. I can also show you that if I would say, for example, this is now 8 o'clock. If I make it 9 o'clock, then it should still work. Because if it hasn't changed after 8 o'clock, yeah, then it also hasn't changed after 9 o'clock. So this will still return 304. But if I make it, let's say, 7, then it changed at 8. So in this case, I will actually get back the full response. That will then again have the right last modified header. So that's how that stuff works. What we can also do is we can make a request to our shallow thing. Now what does it do? Let me show you the controller, because I haven't yet. And what we see here is that I have a method which is mapped on /shallow/someID, and it simply returns some record. Right? This is my model. It's just a record with an ID and a field, another field. And the Spring will calculate a hash base for this thing. So if we call this based on an ID, then what will happen is we're going to get back a response that has the ETAG header here in the response. So now we can use that ETAG header, and we can say I want to do an if non-match. And if we do that, we're going to get back a 304, right? But in this case, I still did all of the work. You can see that if I go to the logging of this caching application, which runs here. It always says returning new model, because yeah, all of that code is still executed. So what if we want to do deep tagging, deep ETAGs? And that's something that I don't see a lot, so that's why I wanted to address it in this presentation. In the same controller, which I need to make a bit bigger, we have another controller method, which is this one that's mapped on /deep, right? So it's not handled by the filter. And what you see here is that again we're adding this servlet web request. This is this Spring wrapper around your HTTP servlet request, but that thing has an interesting helper method, as we'll see. So what happens? Let me walk you through it. We're going to extract the if non-match header. The client may or may not send this. We don't know. Then we need to come up for the given ID. In this case, we need to know what like the real ETAG value should be of the actual up-to-date resource. In this case, I'm just faking that. But this could come from metadata that you cache from an S3 bucket, for example. Actually, S3 has built-in ETAG support. If you retrieve an S3 metadata blob, it will actually include already a value that's suitable as an ETAG. That's how we're using this in my project as well. And then we're going to say if the client did provide an if non-match, because otherwise we don't have to check, then we're going to call this check not modified. And the check not modified doesn't only check. It does check, so it checks if the value that we are passing in is actually the same as the value that the client passed in. But if that is true, if it is not modified, then this check not modified will automatically return a 304 without a response body, and then we're done handling the response. So that means that we can simply return null if this thing returns true, the check not modified. If it doesn't, then the ETAG value is not the same. So then we want to add the correct ETAG header value in our response so that the client actually knows, this is the thing I should be sending. And that's what we're doing right here, right? We're creating these HTTP headers, we're adding the ETAG header, and then we are returning a response entity that has our model and the headers. What's interesting is that here we are wrapping this value in double quotes ourselves. And that is because in this case, the ETAG that's passed in doesn't have double quotes already. Or not that's passed in, but that I derive here myself, I should say. It also works if this thing does have double quotes. So this method, check not modified, it supports both. You can provide it with or without double quotes. But whenever you add this thing to the response yourself, make sure that there are double quotes. So that's basically the idea of ETAGs. There is more to this. You can also sometimes see ETAG headers with that start with a /w, for example. That's like a weak hash. But this is, I think, what is good to know. And this can make a huge difference to your application if you use this effectively. We've had some use cases where clients were really pulling for certain resources. For example, in this business I'm in, we also have things like online casino. And certain games have certain jackpots and certain jackpot values. So we need to tell clients how high is the current jackpot. And that thing changes like every minute or so. So this is something that we actually send out with an ETAG value. So clients can pull maybe every 10 seconds for like what are the current jackpots. But it's super cheap for them to do that because we're using deep ETAG caching for this. So for most of the requests that the client sends, we can just return a 304. We don't really have to do a lot of work. Right? So that's why this is something I think that's really nice. But not many people know that this is something that's built in actually in Spring Web. So you just have to use the servlet web request for this thing. Okay. Also, you need to think, of course, if you want to apply this yourself, to where caching would make sense, right? Not everything makes sense. And if it does make sense, should you use shallow or deep? There might be more cases than you think where this is useful. Right? Like I said, even if you have something that changes like every minute, if you have enough clients that will actually pull for a certain resource, even something that you can only cache for a minute will still benefit from doing caching. Just not sending out stuff on the wire itself is already not only a performance issue, but performance benefit. But it can also be a huge cost saver, right? If you're running on public cloud, you're actually paying for egress, right? This is money that you're saving by doing caching. What you should make sure of, however, is that the clients that you have for your REST APIs actually respect the headers, right? Because who knows, maybe they're using some client that says, yeah, fuck it, I'm just gonna make a request and I'm never gonna include any headers. And then you can do all of the nice caching you want, but you won't see anything. So this is something that we always make sure to tell clients very explicitly. We document this stuff and we check it especially, right? Trust but verify is what they say commonly. So that's important. Now, in my platform, which is an integration platform, we're not only handling incoming requests, which is what we talked about just here, right, with things like caching and error handling. We're also making outbound HTTP requests. So we are calling other systems or our own services. And for that, it can be very useful to include some logging. But if you're using a REST template or a REST client, which is like the follow-up of that, that one does not provide logging of requests and responses by itself. It's not built in. One of the reasons is that these things are really just wrappers around some other HTTP client, which could be a JDK built in, or it can be an Apache Components HTTP client, or an OK HTTP client, right? There's all of these different libraries that are supported. However, the logging support of those underlying clients is very often not suitable for running in production for a number of reasons. First of all, there is zero filtering or masking typically of the logging that it produces. So you see everything about the request, and then you see everything about the response, all of the headers, the entire payload, and that has various issues. You could be logging secrets, right? Maybe I'm doing basic authentication, and now we're sending we're logging all of the headers, not a good thing. Or JWTs, that's remained valid for a while. It's not something you want to have in your logging. Personally identifiable information, right? I don't want people's email addresses and bank account numbers to be logged in my production log, because then everyone with access to the centralized logging can actually scrape this stuff and use it for identity fraud. And also there's just lots of crafts, right? Logging isn't free. If you need to send logging to a logging system and store it for a week, a month, whatever, that costs real money. So you don't want to log stuff that you don't really care about. Also, with these things, basically logging is either on or off. What we found is that, especially on a production environment, very often you want to, by default, not do logging of all of the outbound requests and responses, but you want to do it on demand, only for certain requests. So that idea is something that we are using for quite a while already, where we enable logging only for certain requests based on simply a request header. We have two headers, one that says, do I want to log the request, and one that says, do I want to log the response? And these headers can also be propagated in a microservices architecture if you have multiple services calling each other, because built in the tracing support of Spring is a feature that is called baggage. And baggage means we're going to propagate certain values downstream in the form of HTTP request headers, actually. And this allows you to debug in production, which is really cool. This is not an original idea. So this is actually a link. And what you can see here, this points to a ThoughtWorks technology radar from 2018 already. Right? This is quite old, but they already described this idea of doing per request logging based on something like a custom header here. But I haven't really seen many people using it, and it's super powerful once you do it. And it's actually quite easy to do as well, as I'll show you. So how do you build something like this? Basically what you can do is build an interceptor, a so-called client HTTP request interceptor. This works with the REST template and the REST clients. They share the same infrastructure. However, what is important is that this requires your requests and your responses to be buffered. With responses, that has always been a concern, right? You cannot read a response if it's streamed to your application in your interceptor and then read it again in the code that actually handles the response. But nowadays in Spring, this is also a very common concern for requests, because they made some changes in recent Spring versions where clients try to use streaming of HTTP requests. For example, if you're marshalling something to JSON, instead of saying this, I'm going to just marshal it in memory to a JSON string, and then I'm going to send it out with the content length. What it does nowadays is it just tells Jackson, here's the output stream for the request, just send the bytes. And we don't even know how long the request is going to be, so it's going to be a transfer encoding chunk rather than a content length. But again, that means that if you would try to read that request in your interceptor, then yeah, the regular application code can no longer read it as well. So I'm going to show you how we can actually do this. And then in the interceptor, we can implement whatever we like. Right? We can make sure that we do filtering. We can make sure that we do masking of sensitive information. It's your code, so it can basically do whatever you like. Now, if you have a big project that has a lot of different services with HTTP clients, this doesn't really make sense to have to reconfigure every time, right? We need to create the interceptor. We need to make sure that this buffering is in place. So for this, I would really like to use auto configuration. So I also want to very briefly talk about that. Auto configuration is a Spring Boot mechanism that you probably are familiar with from Boot itself. That is a configuration class with conditions, basically. So at startup, it checks the conditions. If they match, the configuration is active. If not, it's not. That's pretty much it. And this is evaluated after your regular configuration classes. So always does Spring first evaluate your configuration classes, and then it looks at the auto configuration. So it can react on things that you have configured. By the way, when I created this slide, I thought, oh yeah, this is going to be annoying after a while. So I actually looked up how you can temporarily disable an animated GIF in PowerPoint, because I didn't know. So if you want to know, it's the 1 button. If you press 1, it actually stops. However, it just goes again with the next bullet point. Configuration classes also very often provide their own configuration properties classes. This is a way to make sure that you can configure the auto configuration. You can provide it with some input in your application properties, for example. But even though everyone probably uses auto configuration here, not that many people actually write their own auto configuration. And you probably should. It makes a lot of sense to actually do that, either because you want to share things across projects within the company, or like myself, if you are in a multi-module project and you just want to share some libraries between various Java modules. And you can support common things, right? For example, one convention that we always use is that I have a local Spring profile enabled when I run stuff on my laptop, rather than in some deployed environment. Then I can automatically configure certain things, right? If that's a common convention in your organization, in your company, your auto configuration can actually deal with that and say, oh, but if the local profile is active, oh, then I'm going to do some other stuff, right? For example, log more details or something like that. And you can use this for all sorts of stuff. So just some examples of where I'm using this. I'm using this to configure logging and HTTP clients. I'm actually going to demo some of that. We're using it to configure common metrics configuration. We use it to configure things for Spring Security. Configuring Jackson even for JSON. One example is, let's say that you're on Spring Boot 3.3, right? The very latest version that ships with Jackson 2.17. But even Jackson 2.17.1, which is actually the exact version that you get, doesn't have a default implementation of some component that is virtual thread friendly. It actually uses something that is based on thread local caching, which is not a great fit if you want to use virtual threads. So what we actually have is some configuration that says if you have enabled the Spring property to say I want to run with virtual threads, oh yeah, then we're going to reconfigure Jackson. Right? Jackson actually tried to change the default in 2.17.0, and then all sorts of people started to complain about memory leaks and thought, oh fuck, let's release 2.17.1. And 2.17.1 goes back to the original default, and that's what actually ships with Spring Boot 3.3. So be aware of this stuff. But yeah, also the MVC stuff that I showed you, right? Error handling, that sort of thing can also be configured through auto configuration. So how does this work? So in this case, to demo this, I need two projects. Right? I need a library, and I need a Spring Boot service. And that's what I have here. So let me close everything that I have. And what you see here is I have an app, and I have a lib. And if I look at the app, and I look at the dependencies, you can see that it depends on this autoconfig lib, right? Which is this other thing. So what's in the lib? If we look at this, we can see that it has an auto configuration. And in this auto configuration, sorry for this, let me get rid of this and then make this big. In this auto configuration, we are configuring a bean of type REST template customizer. This is something that will automatically be applied to all REST templates that are created via Spring Boot's builder, right? And you can do something similar for a REST client if you want to. I'm going to talk about what this does in a moment, but for now, just bear with me that this thing exists. And then what we have is we have the interceptor. And this is what I want to show you. I'm going to go through this quickly because I'm going to share this code, right? This is in a public repo. I'll show you the URL at the end of the presentation so you can make a picture or write it down. You don't have to copy the code here right now. But what we have here is a client HTTP request interceptor. And it listens to two request headers, right? We have an xlog request and an xlog response. The constructor configures the two loggers that we have there with the default name, but it can also provide another name. And then the real filter code or the interceptor code happens here. We intercept an HTTP request. What we do is we first log if requested, then we handle the actual request, and then we log the response if requested, and then we're done. So this is super straightforward. What do these things do then? If we look at log request here, I'm going to check two cases because there are two different cases where I want to log. If debug logging is enabled for the logger that we're using, I should just always log at the debug level. So that's the first one. If debug is enabled and we have not explicitly asked to not log, because these headers are booleans, I can also provide a false value. If we have not requested to not log it, then we're going to log it at debug. If we are not configured to use debug logging, but we have info enabled, but the client has explicitly requested to do logging with a request header, then we are going to log the same thing, but we're going to log it at info level. Because of course, if we would use debug here, it wouldn't show up in your logging because debug is not configured. So that's the point. For the response, we're doing basically the same thing. If you look at how we create this log message, basically what we want to do is we want to see things like the HTTP method that we're sending. We want to see the URL that we're calling, and we want to see the headers. As an example of how to use configuration with auto configuration, you may not want to log all request headers all the time, right? Or response headers for that matter. Stuff like accept headers, for example, are very often not very interesting to log, but they do take up space, they do take up money if you want to store these things. So in this case, what you can see is that we're checking if a certain header is in an excludes property that we have. And if you look at what this is, we're actually getting this thing from here, this one. So from our auto configuration, what we see here is that this thing has an object called REST client logging properties, right? And it uses this annotation enable auto configuration properties to say I want to make sure that Spring creates that thing and binds my configuration to it. So then I can ask it for the exclude headers. And what that is just a set of strings with names of request headers, right? It's trivial. What we see here is that this is something that I may not necessarily always want to do. So I also want to be able to just disable this stuff completely. So that's why we have this conditional on property that allows me to just opt out of this auto configuration in an easy way. But there is some additional complexity here. And that has to do with the fact that we need this buffering client HTTP request factory, which adds the buffering of the requests and the responses. But it could be that for other reasons, this thing is already configured when we execute this, this customizer. So I need to check if the request factory is already an instance of a buffered thing or not. That's exactly what we do here. So we extract it, and then we check, oh, if it's not already a buffering client HTTP, then we're just going to wrap the factory in that thing. But that extraction is also a bit tricky. That has to do with the fact that Spring actually has a class which is called an intercepting client HTTP request factory that itself also acts as a decorator or as a wrapper to the real request factory. So if I find that thing, then I actually need to extract the underlying request factory. This code is rather ugly, but this is the only way to do this. And this is also code. Actually, I came up with this code by looking at the Spring test framework, which does the same thing, because they also need to look at the underlying request factory, and they use exactly this code with reflection to extract this thing, right? Again, I'm not going to spend like 5 minutes to explain this in more detail. It's just to give you an idea of if you have this in place, then this auto configuration will automatically wrap our request factory in the buffering request factory if that is not already in place. So with those things, we now have code that can perform logging. But we need one more thing, and that's this thing. We have this file here, and this file has this really long name, as you can see here, and it simply lists my auto configuration classes. And starting with Spring Boot 2.7, it searches for this file. Before that, it searches for another file, but the mechanism is similar. But 2.7, 3.0, everything up, this is the way that you create your own auto configuration library. So it's actually quite straightforward. So now, if we have an application here that creates a call, so this one uses a REST template to just request some JSON from HTTP bin, we can have some logging in place. Now, by default, this thing is not configured to use debug logging. So let me start the HTTP bin or the custom application here, then go here. And what we're going to do now is we're first going to make a request where I haven't added any headers and I haven't enabled debug logging. So we're getting a response, and if I now look at the logging of my what is it, HTTP bin control, no, just this one, of this one, then what we're going to see is that here there is no logging of the request. This is just default Spring startup logging, but there is no logging of the request and the response because we didn't ask it to, and we don't have debug logging enabled. So what we can do now is we can make another client request, but now we can include the xlog request, xlog response headers. And if I now do this, and I look again at this thing, then what we'll see is that we're going to get some more logging here, including also trace IDs and stuff, where we see, oh yeah, we were sending a method is get request to http bin.json with a bunch of headers like a trace parent. And also, you can see that we are actually sending here an xlog request and an xlog response. So we are propagating these request headers to any downstream service that may also support this notion, which typically would be our own services, of course. This is not a standardized header. The reason that this happens, because I haven't shown you that, is that in the oh, this is too big. There we go. Yes, in the application properties of the application, I have configured a property which is this one: management.tracing.baggage.remote fields. These are fields that will be propagated as is. So they won't be wrapped in some other request header. They will be provided as is. And this is a very easy way to make sure that if you are in a distributed systems architecture, in the microservices architecture, that this doesn't only trigger logging for the first service that handles your request, but also for everything downstream. We're using this quite a lot to test in production with great benefits, because there are a lot of services where by default you don't want to do this logging. Right? Of course, we could also, for let's say on a development environment, just enable debug logging, and then it will just log every request unless we explicitly ask it not to. Right? So that's basically what that does. And this shows you two things. It shows you how to apply this logging, which I think is a very useful trick to know about. But it also shows you just one use case of how you can apply auto configuration to make sure that by simply adding a dependency on your class path, magic happens, right? That's very often what people think. Oh yeah, Spring Boot is magic, but it's not magic. It's just regular configuration that you can also just opt into to create for your own applications. So that's what I really wanted to show you here. Let's see how we're doing on time. Ooh, it's close. I'm going to do one more demo. And that's the Actuator auto-tune demo, actually. So if you know about Spring Actuator, you know that it provides a bunch of different endpoints. And some of those endpoints include env and config props, which can return your configuration. So you can see all of the different property sources, like system properties, operating system environment variables, application properties, all of that stuff. But of course, some of those configuration things might contain secrets or sensitive values. So by default, in boot, it just masks every value that you have. It doesn't distinguish. Everything will be masked, but you can configure this. So that's the first thing I want to quickly show you. So what we're going to do here is close everything, go to my next demo, which is masking. And then I'm going to start this application here. And what you'll see is that in my application properties, I have configured several things, like some random keys, right? Some of these have names like key and secret, but some of them do not. So what I can do now is I can go to a browser, go to localhost 8080 actuator/env, and what we'll see now is everything is starred out, right? All of the values that we're seeing here, everything is starred out, just as a default way of making sure that boot is secure out of the box. So this is something that you can configure. And here we have two separate properties for that. As you can see, there is endpoint for config props and the endpoint for env that you can say, I want to just always show the values. You can also say, I want to just do it when clients have been authorized using Spring Security. So those are the options that you have here. And if I now restart the application, and I'm going to make this request again, I'll give it a couple of seconds to restart. There we go. Now I see all of my values, right? So this is system properties. I'll collapse that. And then we see operating system environment variables. I'll collapse that. And then we see my application properties. So now I see stuff like Spring application name, which is set to masking. But what I also see is things like some secret, which is set to secret value, right? So now I see everything. It was the case in older boot versions that it would actually try to determine what configuration parameters would contain sensitive information, and it would only hide those. The tricky thing, of course, is what's going to be secret? They don't know, so they had a default like everything that has the word key or secret or token in it or something like that, right? But then there's always people complaining, oh yeah, but you're not catching my default. So in the end, they said, yeah, whatever, we're just going to remove this, right? It doesn't make sense to provide a framework default because this is always application specific. However, you can get this behavior back if you want to. And that's what I want to show you. So you can implement something which is called a sanitizing function, where you can determine what configuration properties should be masked. So for that, we're going to have a look at this class, which is, let's make it big. It is a sanitizing function. This is a functional interface, so it only has one method, which is called apply, that you can see here. And what you can do here is you can you get this data. And then you can ask the data for things like what is the key, and then you can determine what you want to return. So you can say I want to return this thing with a masked or sanitized value, for example. What I do here is I have created a configuration class that simply has a bunch of regular expressions. So if we look at that, I can see what this has. And these are my regular expressions. I say everything that has the word key, password, secret, or token in it, followed by a word boundary, that ones I want to mask. And I do that word boundary here because, for example, if I say something like secrets, secrets.enabled, that sort of stuff, I still want to see those values, just as an example. So now, if we have this in place, and I uncommented the add component, so it should be component scan now, I can restart my application. And with that, what we should see now is that I still see most of my values here, right? This is all plain text. But again, if we collapse these things, what I'll see, if we look at this, is that now for things like some key or some secret, I actually get the start out values, but for everything else, I still see the original value. And you can also determine how you want to mask, right? In this case, I'm using a built-in function to just return a fixed number of stars. But you can also do things like maybe for secrets, show the first and the last identifier. So at least you can check if something is as you would expect without giving away too much information. This is all up to you. But I think it's a nice thing, because if this makes sense for your application, depends a lot on how you are exposing your actuator endpoints, right? You always need some form of security for this, but if you have that, then it's actually nice to say, oh yeah, but most people who already have access should be able to see most of the stuff, but there are certain things that I do not want them to see, because that's like really application sensitive. I'm going to skip this topic, and then we're getting actually already to the end of the presentation. So what I want to leave you with before we start the drinks is that there's more to building production-ready apps than just implementing functional application logic, right? That is important, but you need more typically to create something that actually is manageable and that is maintainable in a production situation. And Boot is a great framework for this, but that doesn't necessarily mean that the default out-of-the-box behavior does everything exactly as you want it to, right? It's a framework for a reason. Everything is configurable, so don't be afraid to tune this stuff, right? I showed you some options, but I could easily do a presentation like 3 hours long where I show more of this sort of examples, because it's super common for our own projects that we do these sort of tweaks and sort of customizations. So for that, you need to learn what your options are. So hopefully I've given you some ideas today. And also, and my final call to action, build mini frameworks for your app, right? What I just showed you with the auto configuration, it's actually super simple to say, oh yeah, it would be really nice if I could just always do this or that. Well, nothing is stopping you from building your own auto configuration library. And that will just do the things that you want. Customize for your logic, right? Including things like common profiles that you may want to support. So it's your mix. So with that, thank you. This is the URL of the GitHub repo that has all of my demos. What I will do, because I think that's actually easiest, right after the presentation now, I will export my PowerPoint to PDF, and I will add it to that repo so that you can just find the slides with the rest of the code. That's nice. But of course, I was making last-minute changes until just before the presentation, so I don't have that quite yet. So my name is Joris Kuipers. Thank you for attending, and I hope you had a good day. Let's start the drinks.